So, if your experience is anything like mine, you've noticed the widespread adoption of AI tools around you, not only in your personal life, but in the workplace. However, in a world where we're expected to embrace this technology, I believe it's truly important we understand how it works. For the next 15 minutes, I'm hoping to debunk the topic of AI to help you better understand this technology and what's going on under the hood. So first of all, who am I? Well, my name's Cameron. I work here at VirtuSales, and if you happen to be on the technology side of publishing, you may have seen me introducing BiblioU AI, a project me and my team have been working on over the past few years that makes use of this incredible technology in a responsible way. However, today, this talk isn't about touting the benefits of BiblioU AI and how it's developed by people who really understand this technology. We'll save that for a later date. Instead, I want to use this as an opportunity to share some of this knowledge with you. And whilst my 6 years of experience with AI will support that, I think we could leverage our connection with the University of Sussex here in the south of England to bring in some speakers who are on the bleeding edge of research and development in this space. So without further ado, I'll pass over to Professor Thomas Nowotny and Professor Julie Weeds.
So my name is Thomas Nowotny, and I work here at the University of Sussex in the computer science department, or we call it informatics. And I've been here about 19 years. My main research area has evolved a little bit. I used to do computational neuroscience, and now I do more bio-inspired AI and neuromorphic computing.
I'm Julie Weeds. I'm a Professor of AI at the University of Sussex. I started life studying computer science back in the 1990s, and I did my PhD at Sussex in natural language processing, completed that in 2003. Back then, natural language processing was quite a niche area, although it's come a long way in the last sort of 25 years.
So I guess I want to get you to take us back to the very, we'll start from the basics. What would you say AI actually is? How would you define artificial intelligence?
Lots of people, AI means different things to different people. I think the definition I would use is one which I think is generally agreed on by researchers, where artificial intelligence is computer systems which carry out tasks which would be generally agreed to require human intelligence. So that includes things classically such as object recognition, communication in natural language, and playing games such as chess, etc.
I think as well, in the industry at least, I've heard the terms machine learning and AI get almost tangled up. Could you kind of maybe tell us a little bit as to why they might be slightly more separate than we think? Or, is it a subset of another? Or
Yeah, I think of machine learning being a subset of AI. So machine learning, for clear definition, in my mind, is where you use an algorithm and then necessarily a computer to run that algorithm to discover something about data. So you have a lot of data and then you do some analysis on it, and that's machine learning. Typically distinguished from expert systems where people inject some sort of understanding or rules into the software as something that starts from tabula rasa, knowing nothing, just analyzing the data and then extracting some sort of knowledge from it. That's machine learning to me.
So almost self-built on the machine side, that it takes understanding from what you're giving it of sorts. Or is that maybe?
Yes, yeah. So all the understanding comes from the data you're giving it, and it's learning from the data, right?
Okay. So where would you say tools like ChatGPT, Claude, these large language models that we see kind of fall into that definition of machine learning?
Yes, so ChatGPT and Claude, as you say, are large language models which have become very kind of prevalent in kind of our world over the last few years. They are machine learning based models which have learnt from large amounts of text. That's where the patterns have been learnt from. Essentially, anything that's a language model is trying to estimate the probability of a piece of text, or find the most likely word to fit in a gap given the context. And that's essentially a language model, and they have been around since the 1990s. Large language models are ones which use neural networks and have been trained on very large amounts of data, e.g. Everything that's out there on the internet.
In your kind of experience, when you make use of one of these large language models, say ChatGPT or Claude, what's actually happening under the hood?
Okay, so what's happening is that the model is trying to generate likely continuations of the text given what it's already seen so far. So it's calculating probabilities of words appearing in the context.
So almost like a really good predictive text of sorts. You give it some text and it thinks, what could come next from that. Okay, so I guess alongside that, we can talk about some of the misconceptions. These types of technology, I think a lot of people, the way they're built out, the platform they use, a lot of people begin to think that the AI model understands them and has memory of them, and it really begins to know you as a person. Is that true in your experience? How does that actually work?
That's an interesting aspect, and I think it's good to sort of understand a little bit more about the training process of the large language models as they go through certain kind of stages of training. So the first stage is what's known as pre-training, where they ingest large amounts of text and they're basically learning to predict what words occur close to other words. Then there's usually some kind of fine-tuning phase where the models are trained to get better at the particular tasks that they're going to be used for. This can be done in different ways, but it could just be giving the model lots of examples of inputs and desirable outputs for those inputs. And then at that point, usually the model is essentially frozen and then deployed for use. So what you see is a model that has been already trained. However, when you interact with it, what you say can be put back into the context for the model. So it's not actually used to update the model as such, but what is actually updated is your prompt. So you say something to you think you're saying to the model, but actually the system appends to that all of the extra information it wants the model to consider as context. And that may be the entire conversation that you've had with the model so far. And therefore it seems as though the model remembers and has learned from what you said previously.
So it's almost making notes for itself of a sort that then it gets passed back so that it has that context and understanding of you and can use that to create a good answer for you.
Exactly.
Okay, so that was a lot of information, and I think it's worthy of a quick recap before we look at these LLMs' behaviours a bit further. So, artificial intelligence is the umbrella term for creating what we would consider intelligent machines. Machine learning is a subset of AI and is the concept of using algorithms to derive patterns from data, essentially using prior experience to make future predictions. Neural networks are a type of machine learning which aim to replicate how the human brain works. This allows us to encapsulate knowledge in a more flexible and trainable manner. At their core, large language models are machine learning models. They use these neural networks and are trained on such a vast amount of data that they can predict the next feasible word, essentially text prediction, but enough so that they can create coherent responses to your questions. And finally, an important point Julie made. These models are frozen at the point of training, so it has no knowledge of you. As you have conversations with it, it doesn't begin to understand and store this information internally. Instead, every time you send a message to the chat, your full chat history and some small notes around you as a person are sent back to the model, and that's how it comes back with the responses. So now we've had a quick recap, I think we should look at some of these behaviours of large language models. First off, hallucinations.
I think the main reason why we have these hallucinations, people often call them, where the models make something up that is not true or which isn't actually related to the data in fact. The typical reason, as I understand it, why the hallucinations appear is because what the artificial neural network inside is doing is just predicting a certain probability of the next word to complete a sentence. And then the actual choice is done randomly. And that means that the most likely word will mostly be chosen, but sometimes also a not so likely word, and that could lead to choosing something that's actually not right, and that's actually not true. And therefore it's a built-in weakness really of the algorithm. But on the other hand, you can't remove it, because it's also a strength of the algorithm, because that's the only thing that makes it generative. Otherwise it would be fully predictable and it wouldn't be creative in any way. So if you want creativity, you get also hallucinations or untruths.
And that maybe explains why you can ask a generative system the same question twice and get maybe fully different answers, or the same answer worded slightly differently, is that they're very intentionally built in this creative manner.
Absolutely, that's exactly what is happening. Yeah? So then the sampling is slightly different, and especially if words are kind of equally likely, then it will diverge into different paths. And if you choose a different word, then what comes next, it's an iterative process. What comes next actually becomes different, and then you diverge and get different answers that way.
I guess that maybe would tie into a bit of a discussion about model bias. These machine learning models, do they have bias within them? Is that something you feel we could remove in the future?
Yeah, I mean, bias comes from the training data. So anything that's been trained is going to be biased to some extent. And you've got to remember what text has been kind of given to these models to train on. So it's been trained on large amounts of internet data. That's going to be large amounts of social media data. That will influence what the model will likely say. There's also potential bias in terms of the kind of fine-tuning processes, in terms of the examples that are given or the humors that are used to kind of rank outputs from the models. Is it possible to remove the bias? I think it's something which we can kind of learn to recognise, but it's kind of really hard to remove bias from humans, so I'm not really sure how we would be able to kind of completely remove bias.
Do you see, obviously we've had this big AI boom, lots of people are looking to adopt and make use of AI. I guess you maybe might be an advocate of responsible use cases for that.
Certainly would like to, yeah.
With that responsibility, where do you think people should head to next? What do you think people should be considering if they're trying to move and make use of these tools?
Yeah, so one simple rule I've made myself in terms of looking at what could be done with AI and what shouldn't be done with AI is that the areas where you can see immediately whether what you're getting is what you wanted, that's an area where you could use it. So let's say you want to use it for programming, and all you want to do is build a nice web page. You use the AI and it builds a web page, and the web page is nice. At that point, I think it's okay, right? You can see whether it's nice or not. Okay. As soon as you want to build something or do something where the AI is trying to fill or supposed to fill in something you don't understand yourself too much of, or you want actually gain knowledge that you don't have yourself, and you can't actually judge what's coming out is good or bad because it's not obvious, then I'd be more careful, because then you're in danger of getting hallucinations, and you can't actually judge whether it is one or not, and you can't tell is this good or bad, and then you're in trouble, potentially.
By exploring both the underlying technology and common pitfalls like hallucinations, we hope you now feel more empowered when making informed decisions about these AI services. Looking ahead, we hope to create a future session on The Harness, which is the specialised framework that sits around these models and ultimately determines their usefulness. This was a critical takeaway from our development of BiblioU AI, where we found the only way we could reliably use this tooling was to create our own publishing-specific harness. The generic ones just wouldn't do. Thank you for listening. Please feel free to follow up with me on LinkedIn to continue this conversation. And a big thank you to Julie Weeds, Thomas Nowotny, and Isaac Baldwin for their contributions to this presentation.